There are two learning points before we start this DE question. It is number one, the net of any rate of change is equals to the rate of water that is going in minus the rate that is going out. Okay? And number two, when dx dt, or rather when the rate is constant or stabilized, sometimes they can use that, it means that dx dt is equals to 0. Now in this question, it says that in a controlled environment, the rate at which the liquid fuel is pumped into a tank is twice the remaining volume. Okay, so that's the first piece of information. The second piece of information is the rate in which the is being used up is proportionate to the square of the volume in the tank. The capacity is 3/2, and the volume of fuel in the tank is x square meter cubic meters. Given that the volume stabilizes at 1 meter cube, okay, show that the increase of the fuel is this. This kind of question is usually worth about 6 marks. Yeah? So first, let me find the dx dt in. The rate of the volume that is in is twice the remaining volume of the tank. It tells you that the capacity is 3/2. The amount of fuel in the tank is x. So this is the dx dt in. Dx dt out is equals to, is proportionate to the square of the volume of fuel in the tank. So I can write it as kx squared. Okay, let me just check again, because it says it's twice the remaining volume, so this guy have to multiply by 2. So my net dx dt is going to be dx dt in, which is, I multiply by 2 first, 3 minus 2x, minus my dx dt out, which is kx squared. So this is my dx dt. The question also tells you that the tank stabilizes at 1 meter cube, or this is where dx dt is a constant, which means that when x is equals to 1, my dx dt is equals to 0. Put this in, 3 minus 2 minus k equals to 0, k equals to 1, and now I have my dx dt equation, which is 3 minus 2x minus x squared. Take out the negative, I will have x squared plus 2x minus 3. If you cannot solve the first part, usually they will give you this given part, and all you need to do is to take the given part and continue to solve. Find x in terms of t. Okay, when I find x in terms of t, this is a very big learning point. I'm going to give you 2 ways to find x in terms of t. Okay, method 1 and method 2. Method 1 is, okay, we go and complete the square regardless of what happened. Yeah, that means once you see a quadratic, you go and complete the square, negative x squared plus 2x plus 1 square minus 1 square minus 3. I will have negative, open bracket, x plus 1 square minus 4, and I'm going to get 4 minus x plus 1 square. Now because x is on my left side, all I need to do is to bring it over as a divide. 1 over 4 minus x plus 1 square dx dt is equals to 1. Okay, if you don't know why this step, you really got to revise your DE first before you look at this example. Integrate dt on both sides. 1 over 2 square minus x plus 1 square dt is equals to, why dt? Because by right is dx dt, and then I cancel it. Sorry, dx dt, and then cancel, I get dx, equals to the integral of 1 dt. This, you have to look at your MF, okay, your MF 27, and this will give you this, my 2 is the a, my this is the x. This will be 1 over 2a, so 1 over 4, ln modulus a square minus x square. Okay, let's check out the MF 27. It says that a square minus x square is going to be 8. You apply it to this, okay? 2 plus x plus 1, 2 minus x plus 1, okay, equals to t plus c. Your plus c always write t on the right side. Yeah. Multiply the 4 over, I will have ln modulus 3 plus x over 1 minus x equals to 4t plus d, where d is equal to 4c. It doesn't matter for now. Okay, so bring the ln over, that will be e to the power of 4t plus d. And to remove the modulus, this step you have to know very well. 3 plus x over 1 minus x equals to a e power 4t, where a is equals to plus minus e to the power d. This step must know very well. Okay, how to make x the subject from here? But before that, they say that the tank is initially empty when t equals to 0. My x is equals to 0. The amount of petrol, the liquid fuel in the tank is 0. Yeah. So 3 over 1 is equals to a e power 0. A is equals to 3. Okay? Then now I put it in. 3 plus x over 1 minus x is equals to 3 e power negative, to power of 4t. Okay? Cross multiply. 3 plus x is equals to 3e power 4t minus 3x e power 4t. Bring all the x to one side. X plus 3x e power 4t equals to 3e power 4t minus 3. Factorize out the x and divide over. I will have 3e 4t minus 3 over 1 plus 3e 4t. Now, however, okay, I think you can leave it as this, because the question never say, yeah, it's in terms of what. Okay, so this is your answer. Okay, but if you do it in another way, which is called method 2, and you can identify that the denominator of the quadratic can be factorized, then I feel that method 2 is a better way for you, because it's easier. dx dt is equals to 3 minus 2x minus x squared. If I factorize this, this will be 3 minus x and then 1 plus x. Yeah. Bring it over. 1 over 3 minus x, 1 plus x equals to dx dt equals to 1. And then I need to break it up into partial fraction. This is something over 3 minus x plus something over 1 plus x dx, okay, equals to the integral of 1 dt. Okay, how to find my partial fraction? You can use cover up rule. So I cover this and I sub x equals to 3. I sub x equals to 3, I will have 1 over 4. And when I cover up, when I use x equals to 1, x equals to negative 1, and I cover this up, it will also be 1 over 4. Okay, so this is how I express this. As I took, so I know both of them are 1 over 4. I take out the 1 over 4. Okay, to form my partial fraction. So this is 1 over 4. When I integrate this will be negative ln modulus 3 minus x plus ln 1 plus x equals to t plus c. Okay, multiply the 4 over. Multiply the 4 over. I will get, and I combine the ln together. 1 plus x over 3 minus x is going to give you 4t plus c. Same thing, bring the e over and then remove the modulus. So 1 plus x over 3 minus x equals to a e power 4t, where a is equals to plus minus e to the power of, this is d, e to the power of d. And then you make x a subject, I believe you are going to get the same answer, okay, as this. Now sometimes the question may ask you to express this in terms of e power negative 4t. Okay, so how do I form e power negative 4t. I need to factorize out the e power 4t over here. Now my first guy will be left with e power negative 4t because, sorry, this will be 1, yeah, because I factorize out e power 4t minus 3. This will have an e power negative 4t inside. Why is that so? Because when you multiply this by this will give you 3. So this is a skill that you need to know very well. Over, if I factorize out e power 4t as a denominator, this will be e power negative 4t plus 3. And so you can cancel and cancel. Then you will get the answer in this form, 3 minus 3 e power negative 4t over e power negative 4t plus 3. Why do they want you to do so? Because there are many questions at the end. They will ask what happens as t becomes large or in the long run. It means as t approaches to infinity, you can only say that e power negative 4t will approach to 0. Therefore, x will approximate to 3 minus 0 over 0 plus 3, which is equals to 1 in the long run, which is what the question actually said at the start, because the question says that the amount of petrol will stabilize, will become a constant, in the long run. Yeah. So the few learning points is when you come and when you see a quadratic over here, there's two methods. It's either you do complete the square and apply your MF, or you check whether you can factorize or not. If you can factorize and then do partial fraction and using the cover-up rule to find the constant, it will actually be faster for you. Remember to remove the modulus by saying that A is equals to plus minus e to the power of d. Okay, and at the end, yeah, if the answer want it to be in terms of e to the power of negative 4t, you need to factorize out e to the power of 4t out from the equation. Okay, and this is a very good example to understand and know for DE.